Okay, this is Appendix B. Not sure which page this is, but I'll have it marked in there. This is just an assortment of equations that we're going to solve. So solve equations algebraically, basically, however we can. So this first one says factor by grouping. So just as a reminder, we're going to group this and this, and we do that by factoring out a term. In this case, it's going to be the greatest term we can, greatest amount we can factor out. So 4x squared, we can factor that out. That leaves us with x and 3, right? Because 4x squared times x is 4x cubed. 4x squared times 3 is 12x squared. So we factor that out. And then over here, we're going to factor out whatever we factor out to help us know how much to factor out is we know that we're going to be left with x plus 3. So in this case, if I factored out 8, negative 8, then I would have negative 8 times x plus 3 equals 0. So then I'm going to group these together, equals 0. Well, actually, let's be specific about what we've done here is we've now grouped them. This all equals 0. So we set each one of these equal to 0. So we'll go 4x squared minus 8 equals 0, and we'll say x plus 3 equals 0. So in this case, x equals 3, and here we have 4x squared equals 8, so x squared equals 2. So in this case, x equals positive negative square root of 2. So our solution set here would be x equals plus or minus root 2 and 3. And we write it as a solution set with brackets. Okay, coming over here, we're solving with fractions. We don't like fractions. We want to get rid of the denominators. So we look for the lowest common denominator, which would be 12. And we come in and we're going to multiply both the left and right by 12, because whatever we do to one side of the equal sign, we do the other. So 12 divided by 3 is 4, so that leaves us with 4x. 12 divided by 4 is 3. 3 times 3x is 9x, equals 2 times 12 is 24. We have 13x equals 24. Divide both sides by 13. X equals 24 13th, and we can just leave it like that. Coming over here, solving for absolute value. We did that, I believe, earlier. And we have to do two ways. I'm going to do green. X squared minus 3x equals negative 4x plus 6. So in this case, we're sort of basically treating this like, it's the positive. Remember, because this is like if we have absolute value of 5, it equals 5. Absolute value negative 5 is also 5. So we have to treat it both the positive and negative. Now, the easiest way to do that, the second way, is to just keep what we have in the absolute value the same, okay? And then, but on the right side, we're going to change the sign. So instead of negative 4x plus 6, it's going to be 4x minus 6. In some cases, some people do it, an alternate way of doing it would be to make the first part negative. So it would be negative x squared minus 3x equals negative 4x plus 6. Okay, it really doesn't matter which way you do it. You're going to come up with the same answer. If we were to take this, we would go negative x squared plus 3x equals negative 4x plus 6. But we never want to have a negative x squared, because if we're going to factor and stuff like that, so if I were to go through and take everything here and just multiply everything by negative 1 and everything here by negative 1, then I'd get x squared minus 3x equals 4x minus 6, which is what we had up here. So that's sort of the math behind it. And it's good to know the math behind it, but if you just can remember that when you're solving for absolute value, that what's within the absolute value sign, you're going to leave that the same, but then you're going to do it where it's the same as what you have in the equation, and then you're going to do it like this, where you have the negative of it, okay? All right, now we just do an algebra. So x squared plus, let's see, 4x minus 3x, that's x plus x, and this is going to be negative 6 equals 0. Factor x, 3, 2. This tells me that they're going to be different signs, and this tells me the greater is going to be positive. So positive 3, negative 2. So we have x plus 3 equals 0, x minus 2 equals 0. And so x equals negative 3, x equals 2. Coming over here, let's see, while we're here, let's very quickly test these two. We need to test them to see if they're either of these are extraneous solutions. The simplest way to do that is, let's come up here to our equation. Now we're saying the absolute value of x squared minus 3x. Okay, so absolute value's always got to be positive. So if we take either of these two numbers, negative 3 or 2, and we plug them into this equation, and it's negative, then we know it's not true. So for example, negative 3 times negative 4 is 12. 12 plus 16 is 18, so this one checks out. However, if we take 2, negative 4 times 2 is negative 8. Negative 8 plus 6 is negative 2. So this one does not work. Okay, 2 doesn't work. So that's not one. That's an extraneous solution. All right, now we're going to come over here, x squared. We're going to subtract 4x. We have negative 7x plus 6 equals 0. We're going to go 6 and 1. And this tells me that they're both the same. This tells me they're both negative, negative, and negative. So x minus 1 equals 0, x equals 1, x minus 6 equals 0, x equals 6. And again, we're going to come back in and we're going to test each one of these. So if I put 1 in here for x, negative 4 plus 6 is a positive number, so that checks out. If I put 6 in here, negative 4 times 6 is negative 24 plus 6 was that negative 18, or that does not work, so it's extraneous. So our solution set, x equals negative 3 and 1. Okay, last problem for this page. This problem is very similar to the previous problem, all right? So this problem, same thing. We want to find our lowest common denominator. X squared minus 4 equals x plus 2, x minus 2, right? So x squared plus 4, that is our lowest common denominator. So we're going to go through and we're going to multiply both sides by x squared minus 4, all of this, times x squared minus 4. So let's think about that. This is x squared minus 4, which is the same as x plus 2, x minus 2. So for this first equation here, the x minus 2 is canceling out here and here, right? So what that leaves me with is x plus 2 times 1. So this is x plus 2. I don't know why I put parentheses around it. X plus 2. And then over here, this x plus 2 is going to cancel out of the x plus 2 that would be here. That would be part of this. That leaves me with x minus 2. So 3 times x minus 2. And then minus 6x over x squared. These cancel out. That leaves me 6x. Okay. Let's see, negative 3x minus 6 equals x plus 2, 4x. I added 3x to both sides. And then subtract 2, negative 8. So x equals negative 2. Now, before I put a box around this answer, once again, I'm going to erase all of this. I need to test. So I need to test to make sure that this works. And if I came up here and if I put -2 plus 2 equals 0. And I can't have 0 in the denominator of a fraction, right? Because then it's undefined. So in this case, there is no real solution because x minus 2 is an extraneous solution. We're always going to want, anytime we have absolute value, a variable, so fraction with variable in the denominator, or if we have a radical. In those cases, we're always going to check our solutions. Okay, I guess we'll keep going here. We're just solving various problems. Again, let's see, this looks like I'm going to do some grouping. I'm going to take x squared out. That leaves, 2x squared out. That leaves me with an x minus 3. And we take -6 out. X minus 3 equals 0. 2x squared minus 6. X minus 3 equals 0. 2x squared minus 6 equals 0. X minus 3 equals 0. Okay? I'm not explaining this setup here. Okay? This to this, I shouldn't have to. We're in pre-calculus now. If you're not sure how it is that I'm doing this, you need to see me during access or before or after class, because that's algebra 2 stuff. Okay, so x equals positive negative square root of 3 and 3. Solution set. Brackets around it. Come over here. I'm going to multiply this side by x squared plus x minus 6. I'm going to multiply this side by the same thing, but I'm going to write it as x minus 2, x plus 3. X minus 2 times x plus 3 equals x squared plus x minus 6, okay? So I'm just two different ways of writing it. That is the same as that. Okay, coming back over here, though, I multiply this in. The x minus 2's cancel out. Leaves me with x plus 3. And then I come over here. I multiply this. In this case, the x plus 3's cancel out. Leaves me with 3 times x minus 2. Equals, this cancels that out. That's 4. X plus 3 plus 3x minus 6 equals 4. 4x, what would this be? Minus 3 equals 4, so 4x equals 7. X equals 7/4. Let's see. Well, x squared minus, well, let's just make it easy on ourselves. Okay, we're going to multiply this side by x times x minus 2. And we're going to multiply this side by x minus 2, my lowest common denominator. Yeah, let's see about that. Okay, so this is going to be 2 times x minus 2. This is going to be 3x. right? Because I distribute that in, distribute that in, distribute this in here is minus x squared minus 2x. So we have 2x minus 4, 3x minus x squared minus 2x. Now we have to start just putting everything together. So I'm going to move stuff around. I'm going to move this x squared over here. Let's see, 3x minus 2x is x. Subtract x. That leaves me with plus x minus 4 equals 0. And I feel like I've made a mistake somewhere. Oh, because this was, here's my mistake, is right here. Okay, this shouldn't be, this is -1, all right, times x squared minus 2x, negative x squared plus 2x. So this should have been a plus, this would be a plus, so this would have been 5x, and then we move it over here, 2x, that'd be negative 3x. Minus 4. That should make sense. 4, 1, negative 4x plus, right? Okay, now I've x equals 4 and x equals -1. Right, and let's just, we want to make sure, okay, so if I put 4, let me erase all of this so I can see. If I put 4 into here and here, I'm okay. If I put -1 into here, I'm okay. So my answer, x is -1, 4. Okay. This problem, just really quickly, common mistake here. Common mistake is people look at this and go, okay, I'm going to square this side, and they'll go, okay, well, since I'm squaring this and I'm squaring this, that gets rid of them. The fact I'm squaring a square root gets rid of them. I get this. Okay, that is a common mistake. You can't do that. Mathematically, you cannot do that. As long as these two are connected by this sign, you can't do that. Okay. So we need to break this apart. Well, I should say, yeah, we can't do that. Some people might say, okay, well, why don't we just square this? Now, we can't do what I said before, but you could do this and use FOIL to do it, but it's really, really messy dealing with all of this. So we take one quick step before we do that to make it easy. We are going to subtract square root here. That gives us square root of x minus 20 equals 10 minus square root of x. Now I can go in and I can square both sides. Now when I take the square of the square root of x minus 20, these cancel out, x minus 20. Over here, I've got to use FOIL. All right, 10 minus square root of x, 10 minus square root of x. So I go 10 times 10 is 100. And then I go, well, let's see. That's negative 10x. That's negative 10 root x. And this is negative 10 root x. So that gives me negative 20 root x. And then lastly, I go negative root x times negative root x. That's going to give me a positive square root of x squared, which is just because those cancel out, this just gives me an x. Okay, if I subtract x from both sides, they cancel out. They cancel out. So it leaves me with negative 20 equals 100 minus 20 root x. I'm going to subtract 100 from here, subtract 100 from here. Negative 120, negative 20 root x. Divide both sides by negative 20. And I've got 6 equals root x. Square this, and x equals 36. We did talk about testing it. We just have to make sure if I put 36 in here, that's positive. 36 minus 20 is 16, so that's fine. And 36, so it works there. And we can actually test it. What's square root of 36 plus 36 minus 20? So square root of 36 is 6 plus, let's see, 36 minus 20 is 16. So square root of 16 is 6, is 4. So that's 10. And that's 10. Oops, 10. Okay. Okay. See, we're going to do these two problems and then we're going to call it quits. Same thing I said before. 3x plus 2 equals 7. 3x plus 2 equals negative 7. 3x equals 5. X equals 5/3. 3x equals negative 9. X equals negative 3. Okay. So x equals the solution set, negative 3, 5/3. Okay. Same idea. Yes, we have a negative x squared. I know I said not to do that, but just trust me. I'm going to move everything over here to keep my x squared positive. So I'm going to subtract x. I'm going to add 10. That gives me 0. X squared. If I subtract x, that gives me negative 11x. If I add 10 plus 10, x, 10 and 1, negative, negative. So x minus 10 equals 0. X equals 10. X minus 1 equals 0. X equals 1. Let's go ahead and solve over here. Now we bring everything over to that side. X squared. Subtract 10. Let's see, negative 9x minus 10 equals 0. Factor 10 and 1. This is negative. This is positive. So x minus 10 equals 0. X equals 10. We already had that. And then x plus 1 equals 0. X equals negative 1. All right, we need to test these. So let's look at 10 first. Let's come up here. 10 squared minus 10 times 10. That's 100 minus 100. Okay, as long as it's positive, it's okay. So I'm going to take that check. Okay, even though that equals 0. Then let's go 1. If I go 1 squared minus 10 times 1, well, that's going to be negative, right? It's going to be negative 9. So that cannot work. Let's see about negative 1. Negative 1 squared minus 10 times negative 1. Negative 1 squared is 1. negative 10. That's 1 plus 10. That's 11. That's positive, so that's good. Okay. There's our solution set.